So I realized that I was missing an objective from way back, um, 5, which is 5.2, parallel versus perpendicular components of momentum, which I remember I remember discussing and talking about a lot during class, just because you emphasized a lot that if you are able to break down momentum into these two different components, you can tackle any kind of physics problem so much easier. And also, it's very important to our understanding of uniform circular motion. So this is problem 5P48, where there's basically this kid or Tarzan that's um, swinging from this rope, and this person is 26 kilograms, and at this instant, at the very bottom, the length of the rope is 4.3 meters, and its horizontal component of velocity is 12 meters per second. Sorry, I didn't write it out, it's right here. But A asks what the parallel component of the change of momentum is, which is also the same as asking the parallel component of F net. But in this instant, um, dp over dt parallel is 0, because um, the only force that's acting, the forces that are acting on this person, is not at all in the horizontal direction. Um, there is Fg that's pulling it down, and there is perhaps like a tension force, I guess, that's pulling it up, but there's no force that is slowing it down or speeding it up in the horizontal direction. So because dp over dt parallel is essentially asking for d of magnitude of p over dt times the unit vector of p, and the speed is not changing, it's 0. And for b, it's on the other hand asking the perpendicular component of dp over dt, which we can algebraically change into p magnitude times speed over r. So you plug in what you have. I mean, because it's only asking for the magnitude of this momentum, you can just calculate it as 12 meters per second times 26 kilograms, which is 312 kilograms meters per second, and then you plug in 12 meters per second and 4.3 meters to get 870 kilograms meters per second squared. So the units all make sense. And C is, I think, just trying to test our knowledge of knowledge that F net is essentially, I mean, it's not exactly the same, but essentially the same as dp over dt. So B and C are asking the same question. You just change the units and say it's 870 newtons. And for D, so from C we get what F net is, which is 870. And we can say that I should have drawn a free body diagram, but there's a force downward, which is Fg, but there's a bigger force upwards, well, I said Fn, but I kind of take it back. It's more accurately described as Ft, I think. So that's force Ft minus 260 newtons. Where to get the 260? It's basically 26 kilograms times g, which you can say is 10. So therefore that Ft is 1130 newtons. The last part is asking for the basically the spring constant. I guess if you are treating the Ft or the force I calculated in D as a spring force, I guess, which so therefore is equal to the spring constant Ks times the length of stretch. And because the length of stretch is 0.08 meters, which I get from subtracting 4.22 from 4.3. You just divide 1130 newtons by 0.08 meters to get around 1412 newtons per meter.